Hello trig students, today I'm going to make a short video for you on how to graph one period of tangent in a generic tangent function that has the form a tan bx plus c plus d. It's going to be similar to our process for sine and cosine, but there are a few key differences. The first being that the period is pi divided by b instead of 2 pi divided by b. So for us that would be pi divided by 1/2 or 2 pi. And then we're going to find the interval. Now for sine and cosine, we used 0 to 2 pi, but for tangent, we're going to use negative pi halves to pi halves. All right, and then we're going to solve for the middle for x by multiplying everything times 2 to get rid of that 1/2. And we see that the interval is negative pi less than or equal to x less than or equal to pi. Then we're going to take our interval size and divide it by 4. So that's going to be the period divided by 4, or pi halves, and that's going to help us label the x-axis. We have an amplitude here of 2 and a midline of 1. And the pattern that the tangent graph takes is at the left and right endpoints of your interval, you're actually going to have asymptotes, vertical asymptotes. And then in the center, you'll have a point at the midline, and then you'll go up the amplitude to the right and down the amplitude to the left. And you'll know you'll graph your points right if it looks like a line. It doesn't graph like a line though. You kind of start at the asymptotes and curve toward the other asymptote. So that's the pattern that tangent has when you're graphing it. And now we're ready to graph our tangent function. So we're starting at negative pi on the left, and then we're going up by pi halves each time. Next, I'm going to graph our midline. Our midline was at 1. So on the edges, we're going to have these vertical asymptotes. And at the center, we're going through the midline. Then to the right, I'm going to go up the amplitude. To the left, I'm going to go down the amplitude. Okay, so let's move this negative pi halves down a little bit, because we want to plot our point right there. And then you're connecting the dots and going towards the asymptotes. So there's a graph of 2 tan x over 2 plus 1. Okay, but what about negative tangent? How does that change things for us? Well, it doesn't change a whole lot until that very last step. So we're still going to find period by doing pi divided by b, or pi over 4. And then for our interval, we're going to do negative pi halves less than or equal to 4x minus pi less than or equal to positive pi halves. And then we're solving for x in the middle. So I'm going to add pi to each side. And then divide by 4 on each side. And then we're going to take the interval size and divide that by 4, which is namely taking the period and dividing it by 4. So we're going to be adding pi over 16 on the x-axis. That's how we're going to generate our tick marks. The amplitude of this guy is 1, and the midline is 1 as well. But it has a negative pattern, a negative tangent pattern. So a negative tangent pattern, you still have the asymptotes, and you still are going through the midline at 0, but now instead of going up to the right, you're going down to the right and up to the left. Okay, so it's kind of the flip over the x-axis of the last function, the positive tangent. Okay, now let's set up our axes. Okay, we're going to start at pi over 8. And we're going up by pi over 16 each time. So the next one will be 3 pi over 16, then pi over 4, then 5 pi over 16, to 3 pi over 8. And each of those tick marks is pi over 16 away from each other. Okay, so let's draw our vertical asymptotes and the midline. And in the center, we're going to go through the midline, and then we will go down the amplitude to the right, up the amplitude to the left, and then connect the dots and go towards the asymptotes. So there's our graph of negative tan 4x minus pi plus 1. Let me know if you guys have any questions or need to see more examples. I'll see you in class.